Well, good afternoon, calculus students. I told you I'd be making a video on infinite limits, so here we go. This should go fairly quickly since we talked about it a little bit in class, but I just wanted to reiterate it and also kind of show you what I mean graphically as well. So, real quick, by definition, I guess, a limit in which f of x increases or decreases without bound as x approaches c is called an infinite limit. So that just means if the graph goes off to infinity based on what x is approaching in our limit, then we're going to actually be able to say infinity or negative infinity as opposed to does not exist because of unbounded behavior. All right, so I want us to start off with a basic limit. So it says the limit as x approaches 2 of 3 over x minus 2. And with any, just like with any other limit, you really should start with direct substitution. But this time that would give us 3 over 0, okay? And so that's still an issue, all right? But it's not the same type of problem like 0 over 0. Because if you, look at it. You can't factor it. So you can't reduce it that way. It doesn't have square roots in it, so I don't have to worry about the domain, but I also can't rationalize. It doesn't have absolute values, so I can't make it a piecewise. And the limit's not approaching infinity, so I can't use that rule either. Okay? It doesn't have trig in it, so it's like we can't do anything else we've talked about. All right, so I'm going to take a second. I'm actually going to graph this thing. All right, so this is a rational function. All right. That means it's got the two swooshes. All right, so we need to know where our vertical asymptote is, and that comes from the denominator. So that the denominator would equal 0 when x equals 2. So we're going to have a vertical asymptote at x equals 2. All right, so let me get that in. And then we have to remember our horizontal asymptote rules. Okay, which because the degree of the top is less than the degree of the bottom, it's going to be at y equals 0. Now, if you remember us talking a little bit about horizontal asymptotes the other day, technically you could take the limit as x approaches infinity of this function to find the horizontal asymptote. Okay, now I just need to know where the swooshes are. So technically you're just supposed to pick other x values. For example, if I plugged in 3 for x, I would get 3 divided by 1, which is 3. So that means I would have a point at 3, 3, so this swoosh must be in this section. All right? I definitely can't have a swoosh under it, so then I just need to pick something before my asymptote, like 1. And if I plug in 1, I get, let's see, 3 over negative 1. So 1, negative 1 would be a point, so I must have a swoosh in this quadrant, or this section, okay? So there's my graph. All right, so let's look at the limits from the left and the right. All right, so if I ask you for the limit as x approaches 2 from the left of this function, okay? Then, again, I still have to find where x equals 2, but it's an asymptote. But that doesn't matter because I'm approaching 2 from the left. I have to be on my graph, getting closer and closer to x equals 2 from the left. Okay? And it's going down forever. It's getting closer and closer to the asymptote, but it is going down forever. So instead of saying unbounded behavior, we actually can say we know for sure that it's going down forever to negative infinity. Okay? And then I'm going to do a similar thing with the limit as x approaches 2 from the right. All right? We already know direct substitution is 3 over 0, so that's why we're looking at the graph. All right, so again, here's x equals 2. It's an asymptote. And as I approach it from the right, I have to be on my graph coming in from the right. I'm going up forever along that asymptote, so we can say that that one is approaching positive infinity. Okay? So now we need to go back to the actual question, which asks you to find the limit as x approaches 2, okay, of our function. And it did not specify left or right, which means both. And so now we're comparing the left and the right, and they do not match. So does not exist, but you're not going to be able to say the unbounded behavior anymore. You're just going to say left-hand limit not equal to right-hand limit. Okay? So again, unbounded behavior will no longer be a reason. Okay? So then what is our indicator that this is the type of problem that we're looking at? That it's going to be some sort of infinity. Okay? And so we can even write that down just so you have it written down. All right? So when the limit equals a number other than 0 divided by 0, all right, that's a good indication, all right, that it could be an infinite. All right, so that's your indicator. Now, to actually find it, okay, to find which infinity, all right, it might go to, all right, you're actually going to plug in, like mentally check, plug in a number a tiny bit to the left and or right, depending on the question. Okay, it might only ask you for one or the other, and see what happens. Okay. All right, and that is kind of what we mentioned in class. We plugged it for that number 11 from your last homework, but we're going to do some more here. All right, so here's my first question. Find the limit as x approaches 1 of 1 over x minus 1. And direct substitution gives me 1 over 0, which is still not okay. Oh, we're just not going to say undefined, okay? We need to see if it's an infinite limit, okay? But to do that, we have to check from the left and the right. All right, because I did not specify one or the other, you have to check both. Okay? Now, yes, we could take the time to graph this thing, and it'll be very similar to the one we graphed at the top, but you need to be able to do it without a graph. Okay? So, what I'm saying here is, since I'm approaching 1 from the left, right, that means I'm coming in from numbers that are slightly smaller than 1. I mean super, super slightly smaller, okay? And so if I plug that in for x, and then I subtract 1, I'm going to get a really tiny negative. I mean super, super tiny, okay? And what happens when you divide by an extremely tiny decimal or fraction? You blow up really big, okay? And so the answer to this is actually negative infinity, all right? Because what I'm saying is, okay, we have 1, and I'm dividing it by a super, 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 super tiny number, all right? And so then it blows up super, 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 super big, okay? All right, now if I do the same thing from the right, okay, that means I'm going to be plugging in something just a tiny bit bigger than positive 1, right here, just a tiny bit bigger, all right? And so when I subtract 1 from that, I'm going to get a really tiny positive. And so if I divide a positive by a really tiny positive, I'm going to get positive infinity. So now when I go to answer the original question, all right, which did not specify left or right, I need to compare the left and the right, and I did it again. Let's not use equals, okay? Again, it does not exist. Take a second here. Okay, so we're going to say this one does not exist, but not because of unbounded behavior. That you can't use that as a reason anymore. Left-hand limit not equal to right-hand limit. Okay? Now, in the next example, all right, I've squared the bottom. Okay, so the bottom is always going to be squared, all right, in this particular problem. So direct substitution still gives me 1 over 0, which is still not okay. But think about what our process will give us. If we check one from the left, but the bottom is always squared, and again, I'm saying a tiny bit to the left, inside the parentheses we will get a negative, but then we're going to square it, so it's going to be a really tiny positive. All right? And then when I check the limit from the right, the same thing's going to happen. Inside parentheses is going to be positive, but when I square it, it stays positive. And so that one is also positive infinity, which means this limit has an answer. Okay? It has an answer. It would actually be positive infinity. All right? And if you looked at the graph, let's see, it would have a vertical asymptote at 1. So, all right, it would look, and a horizontal at 0. And it would look like this. Both sides would go up, and here's 1, right? So as I approach 1 from the left, I'm going up. 1 from the right, I'm going up. And so if they're going up to the same infinity, you can actually say the limit is infinity. Okay? If they were both going down to negative infinity, you could say the limit was negative infinity. All right, so if I were you, I would probably pause the video right here and try the next 2 examples on your own. I am going to pause the video and fill them in. Okay, so it'll be a quick pause for you, but I'm going to fill them in and then they'll reappear. Okay. Okay. So like I said, hopefully you paused it while and tried it on your own. But real quick, number 3 from the left would give us positive infinity because I have a negative 1 on top divided by a really tiny negative. From the right would give me a negative infinity because I have a negative 1 on top divided by a really tiny positive. So overall, that limit does not exist, left-hand limit not equal to right-hand limit. For number 4, because the bottom is squared, whether it didn't matter if I checked from the left or the right, the bottom would both be positive. So negative divided by a really tiny positive is negative infinity for both. So the limit, therefore, is negative infinity. All right, so then on the next slide, I just pulled up problem number 11 from page 79 that we were talking about in class, okay, where you were just checking the limit as x approaches negative 3 from the left, all right? Now remember, because it has a square root, you're supposed to check the domain right from the get-go. You should not be trying direct substitution. You have to check the domain. So you do have to ask yourself, is negative 3 from the left in the domain, okay, of this function? All right, and we talked about that in class. All right, that means like on a number line, all right, here's negative 3, here's negative 4. So I'm talking about something really close to negative 3, but from the left, like negative 3.000001. Well, if I square that, it'll be bigger than 9. So then 9 minus, something bigger than 9 minus 9 is positive. I can take the square root of a positive. This is in the domain. So because it is in the domain, then I can try direct substitution. And that's where we saw in class that we got negative 3 over 0. And now we know that that is definitely not okay. All right, so if that's not okay, you could spend the time rationalizing it, and hopefully you did that in your homework, but that's not going to get you anywhere, okay? And you really don't need to, because you didn't get 0 over 0. that's an indicator it's not going to help anyways. You got that number that's not 0 over 0. Okay, so that's your indicator that is probably an infinite limit. We just need to figure out which infinite, all right, if it works. Okay, now since we're only coming from one side, it should work. Okay, we should get some sort of infinity. All right, so remember we just said we are going to plug in something a little bit to the left of -3. So it's super tiny and close to -3, so you could actually just put -3 on top and you'd be fine. But on the bottom, again, we went through this already. If you plug in that decimal, that -3.000001, and you square it, it'll be a little bit bigger than 9. So when I subtract 9, it'll be a really tiny positive, and when I take the square root of it, it'll still be a really tiny positive. So on top I have a negative number, might as well just say -3, and on the bottom I have a really tiny number. And so remember, when I divide those, I'm going to get some sort of infinity, and because the top number was negative, this is going to equal negative infinity. Okay, so I will write the assignment here, but I will also post it in Canvas so that you can, I'm not going to post it in Canvas as an assignment because you're only going to do the odds, all right? And so you can check all of your answers, and then you can just ask me questions about it in class. All right, see you in class.